Join. Example. So can you hear me? Please join. So sorry for the interruption. There is some technical problem. Example. Okay. So in point 3, some variables are not directly observable. So can you hear me? Please join. So sorry. Some variables are directly observable and some are not. For example, the distance between 2 points inside the scalp of a human being, these are not directly observable because for this we need surgery, but it is not always reasonable. But some, it may be related to some other external distances which are directly measurable. If yes, Ankita, if a relation exists, if a relationship exists, relation, if relation, if a relation exists between the internal distance and other external distance which is easily measurable, it will be very helpful. It will be very helpful. Next point, some variables are immediately available and some are not. The yield of a crop is an example of a variable which is not available unless the crop is ready. But it is related to the amount of rainfalls quality of soil and the amount of rainfall sorry amount of rainfall, quality of soil, the amount of the fertilizer used. If this relation is used to predict the yield, if this relation is used to predict the yield, this will be useful in advance planning of the export policy. Sometimes the relationship among variable is exact. Among variable is exact. For example, the formula in physics or mathematics such as, for example, S is equal to ut plus half ft square, where S stands for distance, t for time, u for initial velocity, f for acceleration, or you can use PV, you know this formula also, PV equal to RT, or another formula T pi equal to T equal to 2 pi root over L by G, where P stands for pressure, V for volume, R for this T for period of oscillations of pendulum, L for length of pendulum. So these are the mathematical relationship or exact relationship. Okay. The exactness of course depend on certain assumptions. This formula depends on certain assumptions. So, but to be realistic, one come across more often with relationships such as y equal to f x1 x2 xn. So, suppose p number x1 x2 xp are explanatory variables plus epsilon, where y is called predict variable to be predicted. This x1 x2 xp, these are called other useful variables. In regression analysis, these are called explanatory variables. And if this function is some mathematical function involving some unknown parameters, and epsilon is a random error, which is the cumulative effect of other variables that may not be known as they are very insignificant and are not included in the relationship. So epsilon is a, again repeat this thing, epsilon is a random error which is the cumulative effect of other variables that may not be known as they are very insignificant and they are not included in the relation. So often even this for example this for linear model, suppose I use only one explanatory variables in linear regression, this is, so this is here is a fx1, so fx1 is nothing but a naught a1 x1. So often even the functional form f is also not known, and one needs to approximate it by a suitable polynomial or some such function. a linear model or statistical model is then a relation of the type y f x1 x2 xp plus epsilon, where f is a, now this f is linear in unknown parameter. Mind it, the, when it is a linear model, then f should be linear in the unknown parameters, and epsilon is the random variable. And here we make some suitable assumptions about the distribution of epsilon, such as we generally assume epsilon is normal variable with mean 0, variance sigma square, and the different epsilons are uncorrelated. This is the, in general we can assume this thing, but it may not be happened. But in this, but here we only restrict that we restrict that the epsilon follows independently normal 0 sigma square. Such linear model can then be used to predict y from x1 x2 xp. This prediction can then be used for planning. So such a linear model can then be used to predict y from x1 x2 xp. This prediction can then be used for planning or betterment of life in general. To be able to do so, we need to estimate of the unknown parameters and estimate has no meaning unless it is accompanied by some idea as to its accuracy. Okay. So the objectives in the linear statistical model estimations of unknown parameters and the variance variances and covariances of these estimates. Next, testing of hypothesis about these parameters is also a part of this study. Hence, just from this discussion we know sometimes variables are not available immediately or directly measurable. In that case, if this variable is related to other variables which are easily available, which we see in the example of crop and the example of the distance between the distance of the scalp. So in that situation we use linear model, and in the linear model if you know the unknown parameters, then you can easily use this model for estimation purpose. And for estimating this unknown parameter we use some method which give you the good estimate of unknown parameters. Not only that, we also find the variance of this variance and covariance of this unknown parameter, and then we apply some testing of test procedure for testing these parameters. So these are the topic in linear model. Okay, so have you any question? Please tell me. So this is the I discussed the problem, real life problem, where it is not always possible to measure the variable immediately or directly. In that situation we use this type of model. Here we mainly use linear model, that is the function the function which is a linear in the unknown parameters, and we approximate these unknown functions by a suitable polynomial, and here we restrict our assumptions epsilon, which is follow independently normal 0 sigma square, and the problem objective is estimate of unknown parameters and find variance and covariance of these estimates, then testing of hypothesis about these parameters. Okay, so have you any question? Please tell me. Pankita, Indrunil, are you there? Please tell me, have you any question? Okay, so Shubhrojit, so the general linear model, first I define the general linear model. The general, this is also called Gauss Markov model. Okay, Shohini, thank you. So the general linear model, also called Gauss Markov model, we denote this by y curve x beta curve plus epsilon curve, where y is the observational vector this x is coefficient matrix whose elements are and epsilon is a vector of error component and beta is a vector of parameters. This is a vector of n observation vector of parameters, vector of random x is a, this is also called design matrix. or coefficient matrix. And this is generally known. This is known matrix. That means the elements of X are known. Vector of error component we assume the epsilons to have following properties. One, expectation of epsilon equal to null vector, and variance or dispersion of epsilon equal to sigma square in. That means epsilons are uncorrelated. That is, epsilon, epsilon 2, epsilon n have the same but unknown variance sigma square and are uncorrelated. So this is the assumption of Gauss Markov model or general linear model. Okay. So this means yi is also uncorrelated and variance of yi is sigma square. Objective is to estimate obtain both point and interval estimation estimate the unknown parameters beta 1, beta 2, beta p, if possible or at least to estimate those linear combination of these parameters. Because later you see that it is not always possible to estimate individual betas. In that case, we can estimate the linear combination of these betas of these parameters. that can be estimated. We also wish to estimate sigma square, and another objective is to test suitable statistical hypothesis about beta, or at least functions of betas usually in the number of observation larger than p, because p is a number of unknown parameters. So for estimating this number of parameters p, we need more observation, and this number of observation n should be greater than p. But we are not assuming this. The rank of x, the design matrix or coefficient matrix, should be, suppose R, then this R should be less than equal to minimum of n comma p. And since n greater than p, then R should be less than equal to p, since n greater than p. If R equal to p less than equal to n, then this model is called full rank model, otherwise it is described as a non-full rank model. In order to estimate beta, beta curve, we need to determine a beta curl hat which is a function of y curl and other quantities like x such that beta curl hat is close to beta in some sense. In that case, if we substitute beta curl hat for beta curl in 1, that is our model y equal to x beta epsilon, y will be close to x beta curl hat. The difference y curl x beta curl hat gives E curl, which is called vector of residuals, while the difference y curl minus x beta curl equal to epsilon curl of the observation from the model value x beta is called the vector of errors. So epsilon is a vector is errors, E curl is a vector of residuals. Okay. And one method of choosing beta curl is to minimize the sum of squares SS of the elements of E curl. And this is well known method of least square. One point is you should note it one point, that is for least square estimation we do not need the distributional assumption. Okay, and under normality assumptions you observe that Actually, if your distribution is uh, distribution of y is normal, in that case your least square estimate and maximum likelihood estimate are same. Okay, so if you do not know the distribution of the observation, in that case you use least square method, and this is the only method. Okay, so this is well known method of least squares, and we shall investigate the properties of estimates properties of estimates means minimum variance estimate, best linear unbiased estimator, unbiased estimator. These are the consistency, these are the properties of estimators. So applying this square method you get a estimates of betas, then investigate the properties of estimates. So the properties of estimates derived by this method. To obtain beta curve hat using this method, differentiate E curl prime E curl, that is y curl x beta curl prime y curl x beta curl, and this is equal to y curl prime y curl minus 2 beta curl prime x prime y curl plus beta curl hat prime x beta curl. Okay, with respect to beta curl and equate them to 0. And the derivative is same as scalar, but you should, one thing you should keep in your mind, that is you should maintain the order. The order of this derivative is p cross 1, so left hand side is p cross 1, then the order of right hand side should be p cross 1. So now you see that x prime y curl, this is a p cross 1, so it should be x prime y curl. Just think like a scalar, derivative of scalar or univariate case. And then if you write beta curl hat prime x, then you see that the order of is 1 cross p, so this is not correct, so you should write this thing. Okay, so now you check that the order is left hand side and right hand side are same, so this is equal to 0 curl, and this imply beta curl hat, so this imply x prime x beta curl equal to x prime y curl. So this is called normal equation. And this normal equation play a very important role in linear model. Now the question is, so this is a system of non-homogeneous equation. So obvious question is, can we solve the equation number 2? So that means the equation 2 is consistent or not. So since the rank of this augmented matrix x prime x, and I augment this column x curl prime y curl, always greater than equal to rank of x prime x, because here we add additional one column, that is x prime y. So the rank of this augmented matrix should be greater than equal to rank of x prime x. I denote this by 3. Now rank of x prime x, x prime y equal to rank of x prime x y. So this is a, so it should be rank so you can think it as a rank of AB. So this should be less than equal to rank of x prime, and rank of x prime same as rank of x prime x. So from 3 and 4 we see that rank of x prime x, x prime y, that is the rank of a augmented matrix, same as rank of x prime x. Hence equation 2 is consistent, that is solvable. But this solution may not be unique, and next question is, according to least square, the solution of beta curve, if you get this estimate beta curve using least square technique, then E prime E should be minimum. So now I check this thing. For this, suppose beta not be any solution of beta curve, it may not be a least square solution, any value of beta curve. That means I want to say this beta curve belonging to RP. Okay, so now So this should be and you can easily check that cross product term should be vanishes because because y curl equal to x beta hat curl. Okay, see that. Okay, y curl x beta hat curl, the cross product term. So this x beta naught, this is the cross product term. Okay, so this should be x prime y curl, x prime x beta curl hat prime beta curl hat minus beta curl naught. So from normal equation this should be 0. From normal equation. Okay, so the cross product term vanishes. So we can write this portion as a sum of these two parts and the cross product term vanishes. So therefore this equal to, so this part is later we will discuss. For timing I denote this by SSA, sum of square due to error, and this equal to m curl prime m curl, where m is x beta curl minus beta curl hat minus beta curl naught. Okay, and this should be greater than equal to SSA. So SS due to residuals, that means which shows that the SS, that means sum of square of the residuals, equal prime equal, is actually minimized by using solution of any solution beta curl hat of, I think I denote the normal equation by 2. Okay, so of 2 and the minimum value will be SSC, sum of square due to error or sum of square due to residual, and we will discuss this thing later. So I want to stop today. Next day we'll discuss estimation of beta, or if it is not possible, in that case we can estimate the linear parametric function, that is the linear function of betas. So if you have any question, please tell me. Otherwise I want to close the stream. So please tell me if you have any question. So this is all about of linear model. Actually, in linear model, this is the basic thing. The objective of linear model is okay, Shubhrojit. The objective of linear model is when it is not possible measure the variable directly or immediately, in that situation, for predicting or forecasting about this variable using other variable which can be available via this linear model. And in the linear model, objective is, if you actually, this is a linear function of the parameters, and these parameters are unknown. You estimate this parameter using least square technique, because we do not know the distributions. And if you assume the observations come from normal distribution, in that case you can uh, perform some testing procedure for these parameters. Okay, thank you Shubhadeep, thank you Shohini, thank you Shubhrojit. Yes, nice day Shubhrojit. Good. So okay, no doubt. Okay, thank you. So we will meet again Thursday. Okay, same time, 10 a.m. Okay, thank you everybody.